our guest is Dr. Andrew Snelling.
So there's a lot of these problems with these dating methods that say they can't be trusted.
And pass it on. Share the gospel clear and strong. Stand for, claim your heritage of truth.
Welcome to Heritage of Truth. Today our guest is Dr. Andrew Snelling. Welcome to Heritage of Truth.
Thank you.
You've done a lot of research on radiometric dating, and people will often cite carbon dating and different dating methods to prove long ages. So what do you say about that?
Well, the radioactive dating methods are the key time indicator that most geologists point to. And in fact, the evolutionists hang their hat on isotope dating. We have to distinguish radiocarbon as slightly different to the long age methods. Radiocarbon, the decay rate is 5,730 years. We call that the half-life. If we have a pound of radiocarbon here, within 5,730 years, we'd only have half a pound left. Half of it will have disappeared. And so the next half-life, another half disappears. So the interesting thing with radiocarbon is that if every atom of the Earth was radiocarbon, within 1 million years it would have all decayed away. And so people say to me, well, you know, there's carbon in fossils, why don't they use radiocarbon to, say, date dinosaur bones? Well, because they believe the dinosaur bones are millions of years old, they don't submit it for radiocarbon dating. But when you do, you find radiocarbon. Now, the interesting thing is that the early method for radiocarbon dating, and I'll come to the other methods in a moment because they're different, but people are interested in radiocarbon dating. The early method of radiocarbon dating, the problem was that you had to shield your instrument from cosmic radiation because the same instruments would detect cosmic radiation, so they had to build a big lead shield around it. And therefore, because there was the possibility of background interference, they couldn't push the dates back as far, all that far. Now, we've got, since the early 1980s, we've got instrumentation that can literally count radiocarbon atoms. And theoretically, you should be able to go back 80,000 years. That's radiocarbon years. So very minute quantities of carbon. But the interesting thing is, when they wanted to calibrate their instruments to make sure that they weren't getting background contamination in the labs, they thought, okay, we'll take a piece of coal that's 300 million years old from West Virginia, and it should have no radiocarbon in it, because remember, it decays so rapidly that after 1 million years you've got none left. So if it's 300 million years old, then we should get no signal in our instrument. They put it in there and they got a signal. And oil, and in fact you can go to the literature, in their own literature, they've got a record of coal, oil, natural gas, bones, shells that all had, fossil shells that all had radiocarbon in them. And it's interesting, I was involved in a research project where we collected samples that were stored by the US Department of Energy at Penn State University in special seal containers from different coal beds all around the US. And we sent samples from 40 million year old coal beds and ones that were over 300 million years old. And they all gave the same radiocarbon age, which of course from a biblical perspective, they were all alive at the beginning of the flood, so they should all give you the same radiocarbon age. Mm-hmm. And yet that people say, oh, but that radiocarbon age was about 49,000 years. But that's assuming that there's always been the present rate of carbon influx. And yet the problem is that the carbon-14 is actually produced in the atmosphere as a result of cosmic ray bombardment of the atmosphere. But if you have a stronger magnetic field in the past, which the evidence shows, the magnetic field protects the Earth from cosmic radiation, then radiocarbon production would have been less in the past. So if you're assuming, when you calculate your age from your measurement, that the rate of radiocarbon production has always been the same as today, you get an inflated age. We even went so far as to say, okay, diamonds. they're made up of carbon. And so we got some diamond samples and sent them for radiocarbon dating, and sure enough, they had radiocarbon in them. Now, the interesting thing about diamonds is the carbon was, the diamonds are formed deep inside the earth, 100 to 200 miles down, and they come up in explosive volcanic eruptions to the earth's surface. And so, and they're the hardest substance known. They can't be contaminated either externally or internally, and therefore the carbon-14 in them has to be intrinsic to the diamonds. It can't have been obtained from the atmosphere. The carbon-14 in our bodies comes from the plants we eat and the air we breathe, and the food we eat, the meat we eat. So therefore, the diamonds had to have acquired that carbon-14 somehow inside the earth. And whether that implies that this is original carbon-14, because after all, when you think about it, as I say to people, God made varieties of animals, he made varieties of plants, he made varieties of atoms. Even though carbon-14 is radioactive today, when God made carbon-12, carbon-13 and carbon-14, 3 varieties of carbon, they may not have been radioactive. So that carbon-14 in the diamonds may go back to the original creation and have nothing to do with radioactive decay of carbon. And so that's interesting, because you think about it. I often say to people, when Jesus turned water into wine, okay, the master of the feast, by using his secular, normal, everyday glasses, assumed that that was wine that had come from grapes grown on vines that had taken a long time to be harvested, crushed, bottled, and preserved, etc. But no, if he spoke to the eyewitness, the servant,
Right.
who filled up the water pot, Jesus turned water into wine instantly. And it was a miracle of creation, because water is not the same as wine. Wine has carbon atoms, water doesn't. Now, the point of the illustration is not only to point out again the importance of the eyewitness account. If you start with the wrong assumptions, you'll get the wrong answer. Mm-hmm. The master of the feast started with the assumption that this was normal wine, but he should have asked the eyewitness. Instead, he asked the bridegroom where the wine came from, instead of the servant that brought it to him. But that's an aside. My point is that wine looked the same as regular wine, and therefore we have to remind ourselves, and I say to people, look, if Jesus can do that then and there, I can believe that he did it back in Genesis chapter 1. After all, he is the creator. That's what it says. And so if he instantly created trees, then if you and I analyse those, the leaves would have had chlorophyll like leaves do today. But it didn't come by normal processes. So when God made the first rocks, they had certain atoms in them. Okay? If we came along later and say, oh, that lead must have come from decay of uranium, therefore we'll use that to date the rock, you'd be wrong, because they may well have been lead in the rock to begin with. Mm-hmm. Why shouldn't there be? And that brings us to the issue of the so-called age of the earth. Most people don't realise that the age of the earth was actually determined on meteorites, not on earth rocks, on meteorites. And that's at first staggering, and that is based on the assumption that when the sun was formed, from the sun coalesced as a star and flung out matter, the solar nebula, and the matter flung out became the planets, and pieces left over were meteorites. The assumption was the meteorites must be the same age as the Earth. And back in the mid-60s, and this was featured in the Cosmos program that was shown recently on television, Claire Patterson at Caltech, he was looking at meteorites, and he was looking at the lead composition of meteorites, and he also took a sample of ocean sediment. Now, ocean sediment on the ocean floor is ground up rocks from off the continents, and he assumed that this was cycling of lead through the Earth's history, from rocks to erosion back into more sediment, became more rock through cycles. And when he found that the sediment the lead composition of the sediment plotted on a line with an age line with meteorites, he said, well, that must be the age of the Earth. And that's where we got the age of the Earth from meteorites. Now, I looked at the meteorites, and they do give a similar age, but it begs the question, if the meteorites go back to the time of creation, is that composition literally the original composition that God gave them? Mm-hmm. We need to remember, and so that initially there were the daughter products as well, like I said with the carbon-14. God made varieties of uranium atoms, he made varieties of lead atoms. And if we come along and assume that all the lead atoms in a rock have come from, or the particular one that were of interest has come from radioactive decay of uranium, if we assume it all has, we can make a mistake. And that's the issue. There are three main assumptions that a geologist makes. He does a chemical analysis of a rock, and then he interprets that analysis. So a radioisotope age or a radioactive age or a radiometric age, they're synonymous terms, where uranium has decayed to lead, and we measure the uranium and lead in a rock. Once you've done the chemical analysis, you've got to interpret that, and there's three assumptions. You've got to assume that there was no lead in the rock to begin with, or you know what the original composition was. Well, were you there millions of years ago to check that rock? No, you weren't. So you have to make other assumptions to assume that you can figure out what the original composition was. Then you have to assume that there's been no contamination. Uranium is a soluble element, for example. Argon, potassium argon is another method. Argon is a gas. It can leak out and it can leak in. It's in the atmosphere, can get trapped in rocks. That's what happened at Mount St Helens. A 10-year-old lava flow gave minerals in it, gave ages up to 2.8 million years for minerals that were only 10 years old. The rock, we'd actually watched the lava congeal.
Which says that the dating system was wrong.
Yes, that's right. And so you've got, what was the initial composition? We don't know. Was there contamination? We don't know. We try to find out whether there could have been. But even when we think that there may not have been contamination, doesn't mean there wasn't, because we weren't there to observe it. And then you have to assume that the rate of decay has been constant at the rate we measure today. And that's not a given either, because during the flood, there were catastrophic geologic processes, and there's evidence of the decay rates might have been speeded up at that time. We did a research in the Grand Canyon where we took samples of a rock unit, of several rock units, and we submitted those samples to the labs for all four of the major methods. Now, geologists don't always use all methods on the same rock samples, because they figure that the clocks should have all give you the same results. If they all start at zero when the rock was formed, then when we get to them today, it's like having like having a grandfather clock and a wristwatch and all the rest of it. They might look different, but they should give you the same time. And so we tested that, and we found that we got different results for the different methods, and sometimes by hundreds of millions of years difference. One of the lava flows at the bottom of the Grand Canyon, the potassium argon age was 516 million years. The rubidium strontium age was 1,111 million years. And the samarium-neodymium age was 1,588 million years. In other words, it was 3 times the potassium argon age. The interesting thing is, there are lava flows also in the Western Grand Canyon that are very similar chemically to the ancient ones at the bottom of the Grand Canyon. These are so recent, you can still see the volcanic cones on the wall up on the rim of the canyon and on the north rim. And the lavas, you can still see remnants of the lavas. They flowed down the walls of the canyon, so they actually blocked the Colorado River. The eruptions occurred after the Grand Canyon had formed. And the interesting thing is, they give a rubidium strontium age exactly the same as the rubidium strontium age for the ancient lava flow. And that tells me, wait a minute, those lavas came from the same source deep inside the Earth, well actually under the top of the Earth's mantle under the Grand Canyon region. So the rubidium strontium age is not the true age, it's an indication of the chemistry of the source. And so there's a lot of these problems with these dating methods that say they can't be trusted. When we have an eyewitness situation with a rock of a known age, invariably the methods fail. And it's not just Mount St Helens. There's been other volcanic rocks that have been tested for various methods of these dating methods, radioactive dating methods. We know the age of the rock and the methods fail. So if they fail on the rocks that we know the true age of, how can we trust them on rocks where we don't know the age?
Wow. That was good. Where can people find good resources on geology
Well, first of all,
that they can understand if they're not scientists?
well, the whole thing is, what I like doing with Answers Magazine is we have an editor for Answers Magazine who's an English major. He's interested in science, he loves science, and he wants to learn science. But he's like the average person in the street, and so I give him my article that's rough and, or it's all the technical stuff, and he turns it into something that's readable. And so it's teamwork. And so if I can explain it to him and he can translate it so that the man in the street can understand it, means the finished article people will understand. And so Answers Magazine I would thoroughly recommend. I try to write one article per issue because I've got a lot of things up here that I want to get written down there so people have that information. Of course, those articles also from Answers Magazine end up appearing on our website. And the website is a good place to go, answersingenesis.org, because you can type in on the search engine, it'll list all the articles that are available on a given subject. And we have it all different, technical through to lay level. So that's one of the best places. Now, we talked about the evidences for the flood a moment ago. I wrote those up initially in Answers Magazine, and they got collected into a pocket guide. We have, Answers in Genesis have these little pocket guides that are assemblages of easy to read articles on a given topic. And we have one on the global flood, we have one on a young Earth, where I talk about the evidence, the radioisotope dating and the radiocarbon dating, which again were originally articles in Answers Magazine.
Okay.
If you want something more technical, well, first of all, we have DVDs of presentations that I've given, and also there's my 2-volume work on Earth's catastrophic past, geology, creation and the flood. When I was working with the Institute for Creation Research some years ago, Dr. Henry Morris had asked others, and he asked me about working on a sequel to his book with Dr. Whitcomb, The Genesis Flood. I might add that book, The Genesis Flood, was instrumental in my life, as it was in so many other people's lives. And so I had the opportunity to work on a book, and that's what the book, The Earth's Catastrophic Past, is. It's an update of and sequel to the Genesis Flood book by Drs. Whitcomb and Morris. I had a good editor that worked on that because I had great big long chapters, and so what he did is say, no, we need to break it down. And so there might be, from memory, 130 chapters, but each chapter is, 5 to 10 or 12 pages long, and it's on a more specific topic. And so I know people who've said, okay, I'll read one chapter a week or one chapter a night, and I'll sit there with a dictionary so I can understand. But quite frankly, it's worth the effort for people if they're really interested in the subject. So those are some of the resources that are available, and I'd like to be able to have the time to write some more lay books, and I plan to. But the trouble is, if I don't do the research on some of these areas and present it at the technical level, maybe others will get the time to do the lay presentations. But if I don't do the technical research, then it won't fuel the translation into the layman's material. That's how I view the ministry in that sense. Is research is so important because it digs deep and provides a technical justification for the position that we take. And I think the scientists should do the best possible research And even if they can't translate it, we have editors like our Answers Magazine article then can make it easier for people to understand. And so when people understand the information, they get excited and they want to support the ministry, which helps support more research, which helps support more lay articles and gets people more excited. And the bottom line, of course, is that we do this simply because we want people to trust God's word, because the gospel is based on the true history. If Genesis is about the family history, starting the family history of Jesus Christ. If there wasn't the first Adam, he can't be the second Adam. If we can't trace Jesus' lineage back to Adam, then he's not our relative who can die on our behalf.
That's right.
And so we want people to trust the history in the Bible, so that then we'll listen to the gospel message, the good news. Because when you think about it, we could have all the best scientific arguments in the world, and we can convince people that there was a creator. But unless we introduce them to the creator, they're going to go to hell like everyone else who doesn't believe.
That's right.
And so unless we point them to the gospel, we're wasting our effort. But the science is a means to challenging people to consider the truth of God's word and therefore listen to the gospel message.
Well, I want to thank you so much for all the research you've done, and a lot of it was instrumental in my coming to Christ. And
That's
I
wonderful.
Just really appreciate.
Well, that's what we're here for.
That's right.
And God gets the credit. And I like to tell people around here, it's teamwork. Some people here have to keep the building clean and the museum clean.
That's right.
But unless it's clean, people don't come. And everybody has a part to play. People who are artists, people who are writers. And so it's teamwork, and God gets the glory, because I can't convince anyone with my arguments. I can't convince them with the evidence, because ultimately it's the Holy Spirit that does the convincing. But I have to be faithful in doing what he's called me to do, just like you're being faithful in doing what you're called to do and getting this information out in a way that people will understand. So thank you very much. It's been great to talk with you.
Yeah, it's been great to talk with you. Thank you so much.
Pleasure.
Share